Alright, so a parabola is the collection of all points the same distance from a fixed point, which is called the focus, as they are from a fixed line called the directrix. Okay, let's kind of sketch this in and then we'll learn some other words that have to do with parabolas. Typically we are used to parabolas that go upward because we are used to calling them functions. So just for fun, let's do one that is not upwards, that instead is sideways, because they can go any direction. Okay, so here's a parabola, and my parabola has a focus, and my parabola has a directrix. Okay, then going this direction through the focus and perpendicular to the directrix is a thing called the axis of symmetry. Have we heard that before? Pretty sure we've talked about that before. So axis of symmetry is going through the focus perpendicular to the directrix, and it's called the axis of symmetry because it's symmetric on both sides. Alright, then we are going to be using a variable that we will refer to as A in the formula I'm going to give you. And A is the distance right here on the axis of symmetry from the focus to the, what's this point right here called? Vertex. Good job. Way to remember that. So that point right there is called the vertex. Okay, so important vocabulary here. We have directrix, focus, vertex, axis of symmetry, and then there's one other thing that they are going to ask from you on a few problems, and it also helps you to graph parabolas so that they are the right width. Okay? There's another line right here, and the length of that line is 4a. So you know how this distance right here is a from the vertex to the focus? Well, the distance from the one side of the parabola to the other side of the parabola across through the focus is 4a, so 4 times the length of that. This line here is called the Latus Rectum. Yes. Lovely vocabulary, right? I'm sure they're related somehow, but I'm not a health teacher. Okay. So the Latus Rectum is a length of 4a. And it's from one side of the parabola to the other side of the parabola going directly through the focus, 4 times the length of that length right there. So that helps you find the width of your parabola. Okay? This particular graph that I've drawn can be represented with the equation y squared equals 4ax. So we now have a in there that applies to our graph. And also this particular graph, where is the vertex located? The vertex is at 0, 0. Do you think the vertex always has to be at 0, 0? No. Okay. So let's talk about what our equations would look like if the vertex has moved somewhere else. And so I need you to think back to a little bit of when we did circles or when we did the transformation disco. Okay? Alright, so there are 4 different directions that a parabola can face. Why 4 different directions? There's 4 different ways, right? There's up, down, there's left, and right. Okay, so one that opens to the right would be like the one we just did, but we can do y minus k squared equals 4a minus h squared. Do you remember when we did do circles that we had h and k was our center of our circle? And h always went with the x value and k always was the y value. So notice how the h is with x here and the k is with y over here. And since they're in the parentheses, are they going to move the direction that it looks like they'll move? No, they're going to be the opposite direction. So this vertex will be located at positive h, positive k. Alright, so help me with one that would open to the left. What would that look like? Opening to the left would be the reflection of opening to the right. So all it would do is include a negative here at the front. That's the only difference. So it's going to be negative 4a x minus h squared. That one will go to the left. And of course, where's our vertex again? I did something terribly wrong. If I'm putting squareds both places, that turns it into a circle or an ellipse or a hyperbola, depending on what the numbers are. A parabola only has one thing squared. In this case, the y is squared, but not the x. I got confused. Sorry. Okay. Now, there's the kind we've talked about before that opens up and down, and those are functions. So instead of the y being squared, the function ones that we've talked about before, what is squared? The x is the part that's squared, right? So we're going to write it like this. X minus h squared equals 4a times y minus k, and no square on that. And then one that opens downward, how do you think that equation is going to look different? X minus h squared equals negative 4a times y minus k. HK. The vertex is always HK. Vertex HK applies to all four situations. Now, is this 4 different equations to memorize? No. It is one equation with minute differences that changes the direction it's going. So you just need to memorize one equation and then memorize the nuances that make it different. Okay, don't try to worry about memorizing 4 completely different formulas. And honestly, these are formulas that you are allowed to use on the final exam. They were on that paper that I put up here last time for your tests. Okay? So if they're not labeled or anything though, so you have to be able to know what they do, but they are going to be provided, or at least they have been in the past, so that you don't have to memorize absolutely everything. Okay? Are we good? Let's do some examples. I'm going to stop the video though at that point.